Now we can use the disk method to find the volume of a revolved solid that's obtained by spinning or revolving a two-dimensional section about an arbitrary horizontal or vertical axis. So in this case, the distance to the axis will denote d, and we'll denote the distance from the horizontal axis to the curve as y, where y is equal to f of x, which describes an arbitrary curve. So therefore, the radius of this disk is d plus y, and squaring that and multiplying by pi gives the area of the disk. And then assigning the disk a thickness dx will give the volume of the disk, and then we integrate from x equals a to b to give the volume of the solid. But as we can see, the middle cylinder is hollow, so we need to subtract this volume from the volume of the solid, because we're revolving this triangle about this horizontal axis. So the volume of this cylinder is pi by the radius squared, which is the area of the cylinder, multiplied by b minus a. And that gives the volume of the revolved solid. So you'll see that using the disk method is not always ideal, and we'll learn other methods as we go along. Let's find the volume of the solid formed by revolving this region around the horizontal axis, passing through y equals minus 1. And to do that, we're going to use the disk method. Well, the radius of the disk is 1 plus y, and then squaring that and multiplying by pi gives the area of the disk. And assigning a disk an infinitesimal thickness in the horizontal direction gives the volume of the disk. And then we integrate from x equals 0 to x equals 1, which gives the volume of the entire solid. But we have a hollow section in the middle, so what we're going to do is simply subtract the volume of that cylinder in the middle. So that will be pi by the radius of the cylinder squared, and then multiply by the height of the cylinder, which is 1. And now you can substitute for y from this equation, evaluate the integral, and find the volume of the solid.